Okay, hello, my name is Trigger Collision, and today I will be showing you my birthday polynomial project. So for my birthday polynomial project, I chose Charles Darwin, and some of you guys might know Charles Darwin, you guys might not, but I'm going to tell you some facts about him. And so Charles Darwin was born February 12th, 1809, in Shrewsbury, Shropshire, England. Charles Darwin was a geologist, a biologist, and an English naturalist. Charles Darwin loved learning about the outdoors and what it had to offer. Charles Darwin explored around the world for 5 years of his life on the HMS Beagle. Charles Darwin also dined on exotic animals on his expedition. Charles Darwin, on his groundbreaking expedition, actually developed theories of evolution and natural selection. It actually took 20 years for Charles Darwin to publish his book about evolution and natural selection. So, birthday. So, I already went over his birthday, which was February 12th, 1809, but I'm going to explain how I got my polynomial. So, I got the polynomial function by taking the numbers of his birthday and just putting it into order. So, for example, I took 2x, or I took 2, and I made it to 2x to the 6th power. Then I took 1 and I made it x to the 5th power. And then I took 2 and I made it 2x to the 4th power. And I took 1 and I made it x to the 3rd power. Then I got 8 and I put negative 8x squared, and then I put minus 9. Uh, I didn't add 0 into this because I thought it would just cancel itself out, so yeah. So my polynomial table. As you can see here, this is my polynomial table. It has my all real zeros and my y-intercept, and so I found actually my table values I found all the possible roots by using synthetic division to find which one was a real zero. I found none of them were rational, so I actually had to use Desmos to find the real zeros. So and so to find my y-intercept, I plugged 0 into all of the x values, and that's how I got my y-intercept. Some basic graph information on my polynomial. So my degree of the polynomial, which was 6, and we did see that, which was 2x to the 6th power, so it was the highest exponent. And then my leading coefficient was 2, which was the first number we saw, so 2x to the 6th power, 2. And so my y-intercept, I got x equals 0 and y equals negative 9. We already went over how I got that. And so for my all real zeros, I got x equals negative 1.57 and y equals 0. And I also got x equals 1.32 and y equals 0. So to find these real zeros, there are many methods that you guys can use. There's like GCF, grouping, perfect squares, and many more that you probably find. But for my polynomial, I use Desmos. I use the Desmos graphing calculator to find all the possible rational roots, and I also use synthetic division. So my minimum and maximum. So you find the minimum on your graph by finding the lowest point, and I found my maximum by finding the two highest by finding the highest point, which I actually had two highest points, so I put both of them. So for my maximum, I got x equals negative 1.57 and y equals 0, or you can have the other highest point, which was x equals 1.32 and y equals 0. So I had two highest points, and like I said, but my minimum is x equals negative 1.078 and y equals negative 15.166. It's the lowest point. And so I'm going to go over some stuff on my graph. So I have my y-axis labeled and my x-axis. I have my two zeros, my roots, and my turning points. And the way I found my turning points was that when you're looking at the table values, you can see how the y values increase and decrease. So since they decrease, they decrease, it causes like turning points in the graph. So like if they go up, they're gonna go obviously go upwards, and like go to the right, and like it's gonna go down. So that's how I found the turning points in on my graph. And so my end behavior. The number of turning points on my graph will always be less than 1 degree. This means technically I can have 5 turning points, but I only have 3 shown on my graph. Technically I should have 6 zeros. That's the same, because that's the same number. That's the same number as my polynomial. But instead I have 2 real zeros and 4 imaginary zeros. The graph will rise since my leading coefficient is positive. But if my degree was odd instead of even, then the direction would be different. And so the degree of my leading coefficient decides the direction of the end behavior on my graph. So the leading coefficient decides where my graph goes. If it's going to go rise to the top or rise down or go down. Some historical context of my historical how I linked this to Charles Darwin was I said this would be a graph of his life right here. So I'm gonna start from dot 1. So I say the first dot shows Charles Darwin studying at college and going through life with his adventure. Going through life without an adventure, I mean. So he's just going through no adventure, not what he likes, especially since he likes to go outside and do that stuff. So he's just like, I feel like he was down here at that moment. He wasn't doing what he loved. For me, the second dot indicates when he goes on a 5-year expedition, learns about the theory of evolution. So I would say his life jumps here because he gets to learn about something. He gets to go on his expedition on the HMS Beagle, and he gets to learn about natural selection and evolution, and also gets to, at that time he was dining on the exotic animals, like I said. The third dot, I would say it goes down to here because the third dot shows when he comes back to England, but Charles Darwin can't release his discoveries on evolution and natural selection because the church will say it's wrong, and especially going against the church at that time was always not the greatest solution with stuff because it would end up pretty bad. But I would say the fourth dot jumps all the way up to here because it represents when Charles Darwin can discuss his groundbreaking theories of evolution and natural selection without getting into conflicts or as much, you know. So that's why 20 years later he had to release his book about evolution and natural selection because he's always so scared. But that time he's like, okay, I'm gonna do it. So he got to release it. And I feel like it jumps up it because that hard work they did on that expedition, especially trying to find and look and try to find and connect the pieces. I think it definitely say he jumps up here. So yeah, I want to thank you guys all for listening. I want you guys to have a good day. Also, I have my work um posted with the assignment when I turn it in.